Okay, guys. So, welcome you all in iitians gate classes, and in series of demo classes. This is last demo class for this Gate 2026 May batch. Okay, and we have been discussing different subjects in different demo classes in the previous days. So, in strength of material, which is one of the subject in section 2 of mechanical engineering, and structures module of Gate Aerospace. Okay, and it is very important subject, guys, in Gate Aerospace or GATEMechanical or GATEPYQ or GATEXE. If you take GATEXE, there is one dedicated section is there for strength of material. Okay, so we'll take some basics from that strength of material, and we'll be discussing in today's session more about stress. So I just want to know, guys, what do you mean by stress? Can anyone define stress? What is stress? Anyone? So stress is what, guys? It is what? It is the internal resistance offered, yeah, internal resistance offered by the body against externally applied load in equilibrium is what? Stress. Yes or no? Correct. Now, guys, in basic elasticity, this is the first topic. Okay, stress. Apart from that, also we discuss many things in basic elasticity like stress, then strain. We discuss stress strain relationship. Then we also discuss prior that equilibrium equations. Then we also discuss volumetric strain, strain energy, and many more things, guys. So basic elasticity is like one of the most important topic. Okay, among strength of material subject means all other topics in strength of material. Apart from basic elasticity, another topic which is like beam. Okay, beam, where also there are many topics, subtopics in beam theory. So these two topics, having always weightage of 5 to 6 marks in GATE exam. So we'll start with stress. As discussed, stress is what? Internal resistance, okay, uh, against externally applied load is what? Stress. Okay, so you guys can see here it is mentioned the definition of stress. Okay, so when a body undergoes a deformation under the application of external forces, a restoring or resistance force is induced within the body. The intensity of this force is known as stress, and it is what? Force per unit area. Now, guys, can anyone tell? We all know, right, guys? What is pressure? What is the pressure? Pressure is also force per unit area, right? Then what is the difference between stress and pressure? Can anyone tell? The difference between pressure and stress. Yeah, Tarun, what is the difference between pressure and stress? Vijay, Vishwar, Puneet. Yes. Pressure is external force per unit area, while stress is internal force per area. Stress is resistance created. Stress is self-induced or internal properties. Yes. So correct, Raman. Basically, pressure comes under loads. Pressure is a kind of applied load. What is the stress? Stress is what? It's a resistance to load, right? Okay. Now, guys, this is what the physical difference. Okay. This is what the pressure is what? The kind of load, applied load, right? Pressure is load, right? Yes or no? You all know, right? On a body, what kind of load acts, right? One is normal load, right? Pressure. Another is what? On any physical body. Can anybody tell what two kind of loads? Tangential load, which are shear loads, right? Yes. And normal loads are pressure loads. Okay. So, and there is another loads, right? Can anybody tell on any body there are usually two kind of loads acts, right? What those two kind of force can anybody tell? One is this normal loads and shear loads, right? Huh? Then any other load? Can you guys tell? Yes, body forces. Exactly. Forces due to gravity and body forces. Okay. So you have aerodynamics load, right? This normal pressure and shear loads are what? These are aerodynamics load, right? Or force due to the force due to what? The external, atmosphere. What you will say? So you have the body forces which will be due to gravity, and you have aerodynamics force. Okay. Now, guys, this you guys understood. The pressure is an external load. Now, guys, I'm asking that is like physical difference between stress and pressure. So, what is mathematical difference? Can anyone tell? Mathematical difference between pressure and stress. Both are force per unit area, right? But there is some difference in terms of mathematics. Yeah, Matishyam, you are correct. Pressures always normal to surface, but stress tangent and normal in mathematical way. Can anybody tell? Raman, Puneet, Tarun, what is the mathematical difference? Yes, you are correct, but some extent, not completely correct, Tarun. Okay. So, guys, yeah, you were writing something. Please complete that. Okay. Anyone quickly can respond? Ishwar? Yash? Okay. So, guys, basically, pressure is what? In mathematical form, it is an scalar quantity. Scalar quantity. Pressure is a scalar quantity. What about stress? Stress is a tensorial quantity. Okay, so Tarun, it is not a vector. Basically, stress is a second order tensor. Vector means it requires only direction and magnitude, but stress will require third thing also, a reference plane. Okay, clear guys, everyone? The mathematical difference between pressure and stress and physical difference between pressure and stress. All of you guys clear? Is it clear, Matisham? Okay. Now, guys, this is in general. You guys should know before starting, what is stress and further. So, generally, guys, stress can be of two types. One is normal stress, okay, and another is shear stress. So, normal stress is also known as direct stress, okay, and usually normal stress or direct stress is denoted by sigma. So this sigma is what? Limit delta A tends to 0, delta Pn by delta A. Okay. So delta A tends to 0 means what? Stress is always mentioned at a point. Okay, delta A tends to 0 means a point. Now shear stress usually denoted by tau. Okay, so this is what? Tau equal to limit delta A tends to 0, delta ps by delta A. Okay, so you guys can see there is a arbitrary shaped body. Okay, and there is one point O on which we want to find stress. So first, at that point, what is resultant force due to all these applied loads P1, P2, and P3, P4, and so on. So resultant force not necessary, okay, to be normal to this, reference plane. If you change your reference plane, okay, the angle between this angle between this normal, which is what? Resultant force at point O, and this reference plane will change. Okay, if you change the reference plane. Okay, so that means if you change this angle theta, okay, then what will happen? This delta Pn and delta Ps will change. So that means at a point, if you change your reference plane, stresses will change. Clear? Is this point clear, Tarun? Now, that is why stress is a tensorial quantity. Okay, it's not a vector. Okay. Now, guys, in Greek word, as I mentioned, normal stress or direct stress is denoted by sigma and shear stress by tau. But guys, if you take mathematical form or in basic elasticity, we use tensorial quantity. So when you talk about mathematics, both stresses can be denoted either by sigma or tau. Can anyone say how? Can anyone say how? Either by sigma or tau in mathematical form or in tensorial form. Raman, Puneet, Vijay, how we can note or denote stress in terms of only sigma or tau in mathematical form, so or tensorial form. So here guys, always stress is denoted by either sigma or tau with suffix, which is what? Sigma ij or tau ij. Now here guys, if I equal to j, then it is what? Can anybody tell? Then it is what? It is normal stress. And when I is not equal to j, then it is what? Shear stress. Okay, everyone, is it clear? So this is what a mathematical or a tensorial way to denote stress. Okay, so guys, further, as I mentioned, if you change your reference plane like from NN to MM, what will happen? The resultant force, which is what? Delta P, the angle between reference plane and delta P, the angle between this delta P and reference plane will change. So that means your delta Pn and delta Ps will change. So that means your normal stress and shear stress will change. So that means stress is a tensorial quantity of second order. So that means it depends on what? Magnitude, direction, as well as it will require a reference plane. Okay, clear everyone? Please guys respond quickly, yes or no. Okay. So once you know stress is a tensorial quantity, we can denote, as I told, in a tensorial form or mathematical form by sigma ij or tau ij, where there are two suffix, right? So what I indicates the plane on which it acts. What j indicates the direction on which it acts. Okay, so basically, if you take two-dimensional stress system, 2D stress system, and if your coordinate in this 2D, it is x, y, this is x, this is y. Now you can see stress on this plane. So what is this plane? Perpendicular to this is what? Can anybody tell? So you can denote either by sigma. What is I here? The plane is what? X plane. And what is the direction? Again x. So it is sigma xx. Now if you take here, what is this plane? Perpendicular to this plane is what? Y. So it is what? Sigma y and direction y. Now if you take guys, what is this stress? The plane on which it is acting, this is x plane. So sigma xy. X, and what is the direction? Y. So it is sigma xy, and it is what? A shear stress. Now guys, further corresponding shear will be here, and this is what your sigma xx, and then corresponding shear, this is sigma y corresponding shear. So what another thing you guys need to know here is how I decide the direction of my shear stresses. How I decide my direction of shear stress? Can anybody tell? How I decided my this shear stress is going downward? Anyone? The next is what? Once you know the notation, what is next is what? How you decide the direction of shear corresponding to normal stress. So very simple funda guys. If your normal stress goes in positive excess direction, then what will happen? This is what? Your normal stress. Then where will be the direction of shear stress? Raman. If your normal stress is in going in positive axis direction, you can see this is going in positive axis direction. So where your shear stress corresponding shear will go? Corresponding shear will also go in positive axis direction. That you can see. Now guys, if your normal stress goes in negative axis direction. Now guys, before that, what is tensile stress? This stress is tensile or compressive? Can anyone tell? What you guys mean by tensile stress? What you guys mean by compressive stress? This is tensile. Why it is tensile, Raman? Why this stress is tensile? Why this stress is tensile? When you have a tensile stress, yeah, yes, it is stretching out. Or in a simple word, what you can say, this stress is going away from the section. Whenever your load is going away from the section, it will produce tensile stress, right? This is going away from the section. If you have a load which creates a stress which is coming towards the section, is what compressive stress, right? So it is nothing like that ki your stress is going in negative direction, so it will be tensile. No, right? You have to see physically your load is stretching or compressing, right? So based on that, we decide your stress is tensile or compressive. So this is what tensile stress, and this is what compressive. Okay. Now guys, we were seeing here this stress is going in negative axis direction and it's a tensile stress. So what will be the corresponding shear stress? What will be the corresponding shear stress direction? Negative or positive? So it will be going in negative axis direction. Now is it clear guys how you define stress system? Anybody? Is it clear to everyone? Because these are most important things guys, fundamentals, and that's where people are confused and later on they do mistakes in strength of material, right? Because everywhere you need to deal with stress, right? So guys, this basic sign convention and all these things should be very clear. So this is what here mentioned. This is what here guys mention about sign convention part. Okay, so let's move to next part now. 3D stresses, okay, or stresses on a three-dimensional body. So guys, we discussed an example of 2D stress system. Now this can in practical or in reality, you have three-dimensional body, right? So you will have a three-dimensional stress system. So how do we define three-dimensional stress system? We take an example of cube. So cube have six faces, right? So on each face there will be three stresses. On each face, guys, there will be three stresses. Now, guys, you can take this example of cube. If you take this face, okay, this face, okay, normal to this face is what? X-axis. So this is what X plane. So what is your stress? Normal stress here, sigma x x, because X is the plane and X is the direction. Now if you take this stress, this is what? Again, plane is X and what is the direction? Y. So it is denoted as what? Tau xy, or we can write it as a sigma xy also. Now guys, this is what? Plane X and direction is what? Z direction. So it is what? Tau xz or sigma xz. Similarly, on other plane. Now if you take this plane, you will see what your normal stress is going in negative axis direction. So your corresponding shears will also go in negative axis direction. Now if you take this plane, top plane, so on top plane, what is the normal? YA. So what is the plane? Y. What is the direction Y? So it is sigma YY. Now corresponding shears will also go in positive axis direction. Now if you take bottom plane, if you take bottom plane, sigma YY going downward, so which is negative Y direction, so corresponding shear will also go in negative X and Z direction. Okay, so that's how we define stresses on each phase. Now guys, there are 6 phases, and on each phase there are 3 stresses. So totally if you multiply, what happens? 6 into 3, total 18 stresses coming. But what happens guys, what happens, shear stresses are of complementary nature, that we define when we do equilibrium equation. What is the complementary nature of shear stress? Means what? Your tau xy is always equal to what? Tau yx, and your tau xz is always equal to what? Tau zx under equilibrium, and your tau yz equal to tau zy. So that means instead of what? 18 stresses, right? You have what? 9 stresses. Okay, 9 stresses which are independent. Okay, total 9 stresses will be independent. And same way, out of 18 we already know, on the opposite faces your normal stresses are same. Like you can see sigma xx on negative this back plane and front plane. So total 9 stresses, okay, which are independent. Now guys, this can be written in a matrix form. This can be written in a matrix form. Okay, so how we can write in a matrix form? You guys will see, this 2D we have anyway discussed. Let me write here the matrix form of stress. So here in matrix form, how can we write guys? Look here, sigma ij. Okay, so in matrix form, how you write? The first guys, you will have stress which is what? Sigma xx, then sigma xy, sigma xz. Okay, now guys, you will have what? Corresponding sigma yx, then sigma yy, sigma yz. Then you have sigma zx, sigma zy, and sigma z. Clear? And here we know guys what? Sigma xy equal to sigma yx, or sigma yz equal to sigma zy, and sigma zx equal to sigma xz. Clear guys? Everyone, this matrix form is clear? How we are writing it in matrix form guys? Okay. Now guys, this is for 3-dimensional stress system. Now if you take 2D stress system, for which I have already explained. Now if you take, this is what my xy plane. So normal to this, normal to this is what? My x-axis. So my plane is x, so sigma xx, then corresponding sigma xy, sigma yy, sigma yx, sigma xx, it will go downward, then sigma yy going downward, negative y, so corresponding shear in negative. So if you write 2D matrix for 2-dimensional stress matrix, what it is? It is 2 by 2 matrix, which is what? Sigma xx, sigma xy, then sigma yx, sigma yy. Again, from complementary nature of shear stresses, from equilibrium we will find what? Sigma xy will be always equal to sigma yx. So this is what 2D stress system. Now guys, here you know your stresses in what? X and y direction. Okay, and it is at a point. It is at some point. Okay, it is at some point, suppose O. Now guys, if I rotate my coordinate system, if I rotate my coordinate from xy by some angle theta to new coordinate, some x1 y1, tell me guys, will my stresses will be same in this inclined coordinate system? No, right? Everyone? No, right? My stresses will not be same. So what you need then? What you guys need then? If stresses are not same, because we know already stress is a tensorial quantity, right? So we need a reference plane. If you change your plane, or if you change here your coordinate system, your stress will change, right? So what you need to know stress in new coordinate system? What you need? Yes, what you need? Puneet, Ishwar, Shravani, what you need? You need angle, and angle is given. So how you can find when angle is given by which it is rotated? You need something called stress transformation. Okay, you need stress transformation, exactly, or you need transformation matrix, right? So we will discuss after this what next is what? Transformation matrix. Okay, stress transformation. So you all understood, right, why transformation is required? Because you know stresses in a particular coordinate system, but you can have stress in any angle, right? And it will not be the same, right? Clear? So you need transformation. So transformation matrix we call, and we derive also guys, this matrix is what? Transformation matrix. And during classes we derive also this matrix. Okay, so this is what? Transformation matrix. Okay, so near here we have considered the new coordinate is S and T. S and T, right? So sigma ss. Okay, one more thing guys, this normal stress, right? Normal stress, many times it is written as sigma xx. It can be also written as single suffix sigma x. Okay, so sigma ss is just here written as sigma s, both means normal stress, but in case of shear stress you need to write both suffix. It can't be written like, if you have shear stress, then it will be sigma st or it will be sigma xy. It cannot be written by single suffix. So keep it in mind that. Now guys, you know transformation matrix. Anyway, this is a demo class, so I am not deriving here. So my transformation matrix is given by what? C square S square 2cs, S square C square minus 2cs, minus CS C square minus S square, where C is known as cos theta, S is known as sin theta. So that means basically guys, this matrix is what? Cos square theta, then sin square theta, then 2 cos theta sin theta is known as what? Sin 2 theta. Am I correct? Then again sin square theta, then cos square theta minus sin 2 theta, then minus cos theta sin theta, cos theta sin theta, and then cos square theta minus sin square theta. Okay, now this is one side is what? Your sigma s, sigma t, and sigma st. Okay, and then other side is what? Other side you have sigma x, sigma y, and sigma xy. Now further guys, how many of you have learned transformation, stress transformation? How many of you are aware? Balram, are you aware? Stress transformation? Others? Matishyam? You are aware, right? Many of you, maybe. Right? So guys, yeah, yes, Ravani, you have any doubt? So guys, basically you all have done, right, stress transformation, but how? Considering some triangular element, right? Yes or no? Like this, we have learned, right, stress transformation on a triangle, right? Like this. You have here sigma x x. Okay, let me use the black pen. Then you have sigma yy, and then corresponding shears, which is what? Sigma xy. Now, Shravani, you tell me on this what you have, sigma s or sigma t, because that's where people don't know concepts. Okay, this is what normal. First place, there are few things I will ask. This is normal, right? So anyway, this is what some sigma. So what will be the corresponding shear? This way or this way? Can anybody tell which is correct? Towards down or towards up? Up. Why, Raman? It is correct up. Why it is not downward? So how you can relate? Anyone? Yeah, normal stress is in positive axis direction. Before that, can you tell me which this normal stress is which? S or T? So basically, guys, how you can understand this way? This is initially your x and y direction. Then we are finding what stress. See, this angle is theta. So this will be theta here. If this is theta, what will be this angle? Theta, right? Theta, right? So this is what S direction, and this is what your T direction. Now this angle is theta, guys. So this is what sigma S, right? This is what sigma S, because it is going in positive S direction. So corresponding shear will be going upside, right? This is correct. Yes or no? Everyone? With the sign convention, this is correct. Okay, so guys, always try to understand, concepts, not just, some formulas. Yes or no, Tarun? Vijay? Yes? If you just remember formula, you can't solve problems in GATE exam or in strength of material correctly. Okay, you may get some number, but you should understand how those formulas are. Okay, so this will be tau st or sigma st. Now guys, you understood, right, what this triangular element mean, right? Now guys, so that means here your sigma ss is what? Your sigma ss in on this triangular element is what? From transformation matrix, it is what? Cos square theta sigma xx plus sin square theta sigma yy plus sigma xy sine 2 theta. Clear? Now what about your shear? Sigma st, it is minus sine theta cos theta sigma xx plus sine theta cos theta sigma yy, and then plus cos square theta minus sine square theta is what? Cos 2 theta. So plus cos 2 theta into sigma xy. Okay. Now guys, I'm asking one thing further. If you change your triangular element, what? From this triangular element, you can change that. You can use this also, right? Yes or no? This angle is what? Theta, right? So in this case, guys, if you change your triangular element, tell me guys, what will be this sigma? Will it be sigma? Will it be sigma s? Because we just know some triangle and then stresses on that triangle, right? Will this be sigma Vijay s? Then because we already know this is what sigma s, this is sigma yy, then you have corresponding shear. Here also you can write this is sigma yy, and then we have corresponding shear. You can write it is sigma xy. Quickly, Vijay, Puneet, what it is? Is it same sigma s? Shravani, is this sigma s? Please guys, others. Raman, Yash, Ishwar, Balram, is it sigma s in the new triangular element? Quickly guys respond. No. This is not sigma s. So what it is? I am telling it is no. Shravani, this is wrong. This is not sigma s. So what it can be? What it is actually? Puneet, please respond. But also in this session, Ishwar. Yash, Vijay, others, what it is actually. So guys, if you look this, what is this direction? You are understanding that the normal to this new triangle is what? T. Clear? So it is sigma T. Okay? It is not sigma S. If you change your angle, if you change your direction, your normal stress will not be same, right? You are changing your normal, right? You are changing your plane here, right? So, and perpendicular to this plane, we already know it is T. So it is sigma T. Now corresponding shear, we know this is positive T direction. So corresponding shear in positive S direction. So this is what your S direction. So it is sigma ST. Okay. Now for this new triangle, what is your sigma T? What is your sigma T? So sigma T is nothing but from transformation matrix. It is what? Sine square theta sigma xx plus cos square theta sigma yy then minus sin 2 theta sigma xy. Clear? What is your sigma s or sigma ss? It is cos square theta sigma xx plus sin square theta sigma yy plus sin 2 theta sigma xy. Now you guys are understanding how these two equations are different, both mathematically and what it mean physically, right? So when to use sigma ss, when to use sigma tt formula. Are you guys clear? Yes or no? So these are the normal stresses on inclined plane. It depends on the direction, in which direction it is asked. If it is the t direction, this formula. If it is the s direction, this formula. Clear? Everyone? So in this case, what it was angle? This was the angle. Here, this is the angle. Okay. So this theta, so this was theta. Okay. Now guys, further, what is shear stress? For shear stress, are we have two different formulas or same formula? Can anybody tell? For this sigma st and for this sigma st, are we have same formula or different formula, Tarun? It is same formula. Okay, whichever is the plane, either this plane or this plane, the formula is same, right? So what it means? These two planes are complementary plane, right? Stresses on these are perpendicular planes, right? These are two perpendicular planes, right? Like this. So this is what sigma st, and then this is also sigma st, right? So what is the formula? Sigma st is equal to what? Minus cos theta sin theta into sigma xx plus cos theta sin theta sigma yy plus cos 2 theta sigma xy, or further you can write this as what? We can write it as sigma yy minus sigma xx by 2 sin 2 theta plus cos 2 theta sigma xy. Okay, everyone, is it clear? So in today's class you got clear, right? What is my stresses on a triangular element? It again depends on what, how you have taken your triangular element. It is not random. Shravant, we have 15 plus people. Okay, different people will take different subjects, not me alone. Okay, in IGC for every subjects we have different faculty. Clear? Okay, IGC is not of like one person or two person institute. We are a team. Clear? Okay, so guys, now till now is it clear what is stress transformation? Everyone, all of you, is it clear perfectly? Now you guys will not forget, right? Tarun, you will never forget, right? Sure. When to use sigma s, when to use sigma t, what is the sigma st, okay, how these are complementary, okay, all these things, guys. In simple word, we are not doing any derivation today. but we are understanding physically and mathematically how stresses are. Okay, now guys, this transformation matrix we can write in a two way. Why? How? See guys, sometime in your exam or in literature, what happens? Your stresses are given like this. This is x and y, and your coordinate, this is what? S and t. Okay. Now here this angle is theta. Now in some cases, what is your known? Your sigma x, sigma y, and tau xy is known. So we have already written, right? What is the transformation matrix? It is c square s square 2cs s square c square minus 2cs, then minus cs c square minus s square, and this is equal to what? Sigma s, sigma t, and tau st or sigma st. Now guys, in some case, suppose your known stresses are in inclined axis like this. My sigma s is known, my sigma t is known. So what is your unknown? What is your unknown in that case? This angle is still theta. What is your unknown? If sigma s and sigma t is known and sigma st is known, so what is unknown? What is unknown, guys? In that case, anyone? Raman? Vijay, what is unknown then? It is written already. Can anybody tell? Yes, what is unknown then? Angle is not unknown. Angle is given. Your known stresses are in S and T direction. So unknown is what? Unknown is sigma x, sigma y, and tau xy. So how you find? So what you need to do, simple. In this transformation matrix, instead of theta, substitute minus theta. So your transformation matrix will become what? C square S square minus 2cs, then S square C square 2cs cs minus cs, then c square minus s square, and here known is what? Your known is sigma s, sigma t, and then tau st. Clear? Is this clear now, Vijay, what I was asking? Everyone? So these are two transformation metrics you guys should remember when what is asked and what is unknown. Okay, fine. Now guys, what you guys understand? Now if you change theta, there can be how many value of theta, guys? How many value of theta you can have? 0 to 360 degree, right? Yes or no? So 0 to theta can be 0 to 360 degree, right? That means there can be infinite number of thetas, right? Between 0 to 360. So what happens? There will be one value of theta for which what will happen? There will be one value of theta for which what will happen? Your sigma will be maximum, right? Or sigma will be minimum, right? Your stress will be maximum or minimum. So those value of normal stresses which are maximum or minimum is known as what? There will be one value of theta between 3 to 60 degree, 0 to 360 degree, for which your sigma is maximum or minimum. So these known as what? These known as what? Maximum, minimum. Normal stresses are known as what? Principal stresses. Clear? These known as what? Principal stresses. So guys, the principal stresses are like one of the stress in a transformed coordinate system. Clear? Nothing different. Yes or no? This is one of the right normal stress in a transformed coordinate, but for which what you know it need the value of theta. So what is the principal stress then, guys? Principal stress is what? Or principal plane. So what is the principal plane? So principal planes are those planes on which only normal stress will act with zero shear stress. This is one definition. Another definition is what? Principal stresses are those stresses which are maximum or minimum, or principal stresses are on those plane where no, principal planes are those plane on which normal stress is maximum or minimum. Clear? What are the principal plane known as? So principal plane have two definition. One is what? Principal planes are those plane on which shear stresses are zero, or principal planes are those planes on which normal stresses are maximum or minimum. Clear? So we all know, right, what is the maximum minima condition. So we know maxima minima condition is what? We know normal stress is sigma. So what is the maxima minima condition? Dou sigma by dou theta we equate to 0. We will get the theta corresponding for which principal we will get principal stresses, or we will get maximum or minimum stress. Okay, or we will get the same theta value. How? If you substitute this shear stress to 0, you already know shear stress on inclined plane, right? If you equate that to 0, you will get principal plane. You will get principal plane. So what is the principal plane? If I do this mathematics, you will get theta 1. Okay, so what is the principal plane? Anybody know formula? It is 1 by 2 tan inverse. Anybody? 1 by 2 tan inverse. It is what? It is tau equal to 0. So 0 equal to, it is what? Sigma y minus sigma x by 2 into sine 2 theta plus cos 2 theta tau xy. So what we get? If you find 1 by 2 tan inverse, it will be 2 tau xy upon sigma x minus sigma y. Clear? Is it clear to everyone? The principal plane, how we got? 1 by 2 tan inverse 2 tau xy upon sigma x minus sigma y. Is it clear, everyone? Okay, so this is what first principal plane. What will be your second principal plane? Your theta 2, if you want to find, it will be theta 1 plus 90 degree. Okay, because we know tan 2 theta is nothing but tan 180 plus 2 theta. Okay, so you get theta 1 and then theta 2. And there is alternate way of finding principal stresses. How you can find alternate? Suppose you know your matrix, stress matrix in 2D form. So what is your stress matrix in 2D form? It is sigma ij is what? Is equal to what? It is sigma xx, sigma xy or tau xy, then sigma yy. Now guys, if you find the eigenvalue of this matrix, those eigenvalue will be nothing but principal stresses, and your eigenvector will be principal plane. So how to find eigen values, we all know, right? It will be determinant of sigma minus lambda I is equal to 0, right? So what is I here? I is identity matrix. So this is what short short way of finding principal stresses. Okay, and this method is very handy, guys, in some cases when one of the principal stress is given and some unknown stress is asked on your xy coordinate system. Okay, now guys, if somebody asks me what is the formula for principal stress, you all know, right? Textbook formula. Can anyone tell? Sigma 1 comma 2, how it can be written mathematically? Anybody remember? Tarun, Vijay, Yash, all you have read, right? Strength of material. What is the formula for principal stress? Shravant, Balram, what is the formula for principal stresses? Anyone? Okay, so we all know, right, this formula, sigma x plus sigma y by 2 plus minus under root of sigma x minus sigma y by 2 square plus tau xy square. How many of you know this formula? The plus sign is corresponding to maximum principal stress and minus will be corresponding to minimum principal stress. So the maximum principal stress is also known as major principal stress and minimum principal stress is known as minor principal stress. Clear? Guys, do you remember this formula of principal stress? So when we do classes, we will derive this formula also, guys. Okay. Once we know the theta condition, that theta condition we need to substitute in our inclined stress formula, we will get this formula. Okay. Now, guys, once you know principal stresses, you can also find maximum shear stresses. So maximum shear stresses and plane of maximum shearing stress, how you can find. So again, guys, we know tau st or tau formula, right? Maximum shear stress formula. So now, guys, if you take this again condition, dou tau by dou theta equal to 0, then we will get one value of theta for which will give me what? Tau maximum, and the value of theta for which tau is maximum is known as plane of maximum shear. So guys, what comes usually, this is known as theta 3. So what will be theta 3? Usually when you do this, you will get it is 1 by 2 tan inverse sigma y minus sigma x upon 2 tau xy. Anybody? Is it correct? Yes or no? Okay. Anybody remember this formula? Is it correct, Vijay? Yes or no? Yes. Simple. You know already what is your tau. Your tau is sigma y minus sigma x by 2 into sine 2 theta plus cos 2 theta tau xy. Now you differentiate this with respect to theta and then substitute equal to 0, you will get this one. Is this correct? Yes or no? Please guys, yes or no? Yes. Right? So once you know the maximum shear stress plane, right? Plane of maximum shear stress, you can find also value of tau maximum. So usually guys, tau maximum, the value of tau maximum, guys, the value of tau maximum is given by what? Usually it is what? It is under root sigma x minus sigma y by 2 square plus tau xy square is known as what? and you can write plus minus is what? Maximum shear stress. Okay. Now guys, further, if you find the value of normal stress, the value of normal stress on the plane of maximum shear, what will be the normal stresses on plane of maximum shear? It is not necessary to be zero. So usually it is given by what? It is given by what? Sigma x minus sigma y by 2 or plus. Anybody? What it will be? Let me quickly check and tell you guys. So it is basically the coordinate of Mohr's circle, center of Mohr's circle. So plus, right? Or minus? Let's see. We can do quickly, Raman. I think it should be plus. So this is sigma x. Suppose this is sigma y. Okay. So the coordinate of Mohr's circle. Let me. Okay. So this is what? Plus. Okay. So always normal stress on the plane of maximum shear is given by what? Sigma x plus sigma y by 2. Okay. Because guys, when you draw more circle, you will see this is center of more circle, and corresponding to center of more circle you will have maximum shear. Okay. Now center of more circle, if you find, it will be nothing but what? It is sigma y plus sigma x minus sigma y by 2. Clear? Is it clear, Raman, now? Why it is plus, Tarun? So the normal stress on the plane of maximum shear, not necessary to be zero. It is given by sigma x plus sigma y by 2. Okay. So guys, all these basics we have discussed. Now I think we have spent more than 1 hour. So we can take up some problems, right? So we can take some gate question quickly. Okay, so guys, solve this question. So how was class life? Are you guys finding interest? Puneet, Vijay? Yeah. So guys, now try to solve this question. I'll explain how to solve this question quickly. Yeah, guys. So somebody told A is the answer, somebody told D is the answer. So what is the correct answer? And how to solve this question? Anybody? Can anybody tell me how to solve this question? It is a simple question, right? It has come in, GATE Aerospace paper. So, guys, what is the common in all options? Read the question first, guys. What it says: uh, which one of the following object with inclined face at 45-degree, subjected to the given stresses, are in static equilibrium? Right. So you have to find which one of the this triangular stress system satisfy equilibrium. So what is the common in all options? Can anybody tell what is the common in option A, B, C, D? What is the common? Raman, Puneet? Angle is common. Good. So theta is same. So theta they have mentioned from horizontal like this. If this is 45-degree, we know, right? This is also 45-degree, right? So theta is 45-degree from vertical angle. Then what else common? What else is common? Anyone quickly? What else common? Puneet, Ishwar, what else is common? Hmm? Yes, sigma x and sigma y is common, right? So in all the option, what is sigma x? In all the option, sigma xx is 30, right? Sigma xx is 30. Sigma yy is 40. What about sigma xy? What is the sigma xy? In the all the options, what is sigma xy? Hmm? What is sigma xy? Hmm? Usually we write, right? What it is here? It is not given, right? So what it mean? Ishwar, what it is? It is 35, huh? So you guys can see there is no shear. If it is not given, that means your sigma xy is 0. In this given problem, sigma xy is 0. So now guys, to solve this question, nothing else, nothing you need to do. What you need to understand, they have given one triangular element. If this angle is 45-degree, we know this is also 45-degree. Here they have given sigma xx and this is given sigma yy, and corresponding shear stress they given 0. Now guys, we know from our understanding of the concept, the corresponding normal stress, it is sigma s and this is tau st. Yes or no? Is this clear? Because we have done this triangular element, right? When this angle is theta, this angle is theta, right? This is what? Sigma s and corresponding tau st. Yes or no? So what is unknown here? Sigma s and tau st. Can you guys find out? So what will be sigma s? So sigma s is what? Cos square theta sigma x plus sine square theta sigma y. Now third term is 0. Why 0? Because sigma xy is 0. Clear? Yes or no? Is this clear? Ishwar, is this clear now? Raman? Right. Now substitute. What is sigma x? Sigma x is 30. Angle is 45 degrees. So cos 45 square is what? Cos 45 square is what? 1 by 2 plus sine square 45 is again 1 by 2. And what is sigma y? 40. So what is sigma s is coming? Quickly guys. What is sigma x? Sigma s coming. 15 plus 20 is what? 35. Okay, so this is 35. Now what about guys tau st? So tau st is what? sigma y minus sigma x by 2 into cos 2 theta plus 0. Why 0? Because sigma xy is 0. Substitute here. So what is sigma y? It is 40 minus 30 by 2. Cos 90 is how much? Sorry, it is not cos here, sine, right? It is sine 2 theta, yes or no? Sigma y minus sigma x by 2 into sine 2 theta plus cos 2 theta into tau xy, right? So what is sine 90? Sine 90 is what, Ishwar, Puneet? It is 1, right? Sine 90 is what? 1. Right, Tarun? So what is the answer? What tau st you get? You will get 5. Right? So that means this tau st we got positive value. When you got positive value 5, that means what we consider is the correct direction. Now tell me the what is the answer? Which is the correct answer? You got sigma s equal to 35, right? So you can see A can't be answered, C can't be answered. So it is only B and D. Now you know, right? We got tau st positive. So that means this is the correct direction, right? If you would have got negative means this. So D is also not correct. So what is the correct answer? B is the correct. So this is how you need to solve a problem in GATE exam. Clear, guys? Tarun, is it clear, right? Though we know the concept, but such problem you can't solve until unless you are very clear with all the fundamentals. Clear, guys? Everyone, is it clear? Why B is the correct answer? Yes or no? Puneet, Ishwar? Okay. So guys, should I solve some more question or we can wind up? See guys, this is one of the question. Okay, even without solving you can answer. When you learn all the concepts without solving, you guys will able to answer this question. Okay, so you guys can take picture of this question and solve at home. Then another question, guys, this question. Okay, so this was in recent gate paper. This was asked, guys, in recent gate paper. Okay, so then thank you guys for watching this session, and if you guys have any further query, you guys can contact on this number, or you guys can write a mail to us, or please visit our website to know more courses of IGC. And guys, you guys can subscribe to our different social media platform to get updated with IGC courses, latest jobs, and many more things. Okay, yeah, fine then. Any question if you guys have can ask. Otherwise, we will wind up now. Any question, Tarun, Puneet, Ishwar? Anyone have any question? No question, guys. Okay, then we'll wind up, guys. So thank you guys for watching this session.